Have you ever wondered what things are made of? Why does wood burn but rocks don't? Since the dawn of time, humans have been curious about the world around them. We've always wanted to understand how things work. This fundamental curiosity is what led to the birth of chemistry. In ancient times, people didn't have fancy labs or microscopes, but they were keen observers of nature. They noticed that fire could transform wood into ash. They saw that water could freeze into ice and melt back again. These observations sparked a desire to understand the very essence of matter. For centuries, the pursuit of understanding matter was deeply intertwined with alchemy. Alchemists were a mysterious bunch. They were part philosopher, part mystic, and part early scientist. They believed that metals like lead could be transformed into gold. The alchemists' quest for gold was driven by a desire for wealth, of course, but they were also searching for something more profound, the elixir of life. This magical potion, they believed, could cure any illness and grant immortality. While the alchemists never achieved their lofty goals, they made important contributions to chemistry. They developed new laboratory techniques and equipment. They experimented with various substances, laying the groundwork for future scientific breakthroughs. By the 17th century, a new era was dawning. Scientists began to rely less on ancient texts and more on observation and experimentation. This shift in thinking marked the transition from alchemy to modern chemistry. One of the pioneers of this new scientific approach was Robert Boyle. He emphasized the importance of careful observation and meticulous record-keeping. Boyle also challenged the traditional view of elements, proposing that they were simple, fundamental substances that could not be broken down further. If there's one name you should know in the history of chemistry, it's Antoine Lavoisier. This brilliant French scientist is often hailed as the father of chemistry, and for good reason. Lavoisier was a meticulous experimenter. He insisted on precise measurements. This dedication to accuracy revolutionized chemistry. It allowed him to make groundbreaking discoveries. One of his most significant contributions was the discovery of the law of conservation of mass. This fundamental law states that matter cannot be created or destroyed, only transformed. Imagine a burning candle. The wax seems to disappear, but Lavoisier proved that the total mass of the reactants, wax and oxygen, equals the total mass of the products, carbon dioxide, water, and other byproducts. As scientists delved deeper into the nature of matter, they began to identify and isolate elements. Elements, as you may know, are the building blocks of all substances. Think of them as the letters of the chemical alphabet. Early chemists used a variety of techniques to discover new elements. Some elements, like gold and silver, were known since ancient times. Others, like oxygen and hydrogen, were isolated through careful experimentation. Each new discovery added another piece to the puzzle of understanding the universe at its most fundamental level. By the mid-19th century, dozens of elements had been discovered, but there was a problem: how to organize this growing list in a meaningful way. Enter Dmitry Mendeleev, a brilliant Russian chemist with a flair for organization. Mendeleev's breakthrough came when he arranged the known elements in order of increasing atomic weight. He noticed a repeating pattern in their properties. This led him to create the periodic table, a masterpiece of scientific organization. The periodic table is more than just a chart, it's a predictive tool. Mendeleev used it to predict the existence of elements that hadn't even been discovered yet. And guess what? He was right. From the medicines we rely on to the smartphones in our pockets, chemistry plays a vital role in our daily lives. It's the science behind everything from the food we eat to the clothes we wear. Chemistry is essential for developing new materials. Think lightweight plastics, high-performance ceramics, and advanced alloys. It's also at the forefront of renewable energy research, helping us find cleaner and more sustainable ways to power our world. The journey of chemistry is far from over. In fact, it's just getting started. Today, chemists are exploring the frontiers of nanotechnology, manipulating matter at the atomic level. They're unraveling the complexities of biological systems, paving the way for new medical treatments. As we venture further into the 21st century, chemistry will continue to play a pivotal role in addressing some of the world's most pressing challenges, from climate change to food security. From the ancient alchemists to the modern-day pioneers of science, the pursuit of understanding matter has been a long and fascinating journey. Chemistry has shaped our world in countless ways, and its impact will only continue to grow in the years to come. So the next time you look at a seemingly simple object, remember the incredible world of atoms and molecules that make it all possible.